in this tutorial, I'm going to explain A/B test. And in particular, I'm going to discuss how data type impacts analysis choice. Let me just start with a simple example. Suppose that you are designing an app and you would like to see how different colors of the button can impact some behavior. So you design one version is a blue button and another version is an orange button. Of course, this is a hypothetical example. So what exactly is data type? In this tutorial, I distinguish two types of data. One is numerical data, one is categorical data. Of course, there are different other names for these two types of data. Another point I would like to mention is that, of course, beyond these two types of data, there are other types of data, but in this tutorial, I'm going to just focus on these two types of data. So for numerical data, the example could be like how long people stay on the app. It could be 10 minutes, 20 minutes, or 30 minutes. So this measure like how long people staying on the app. Another type of data could be like whether people click the button. Yes, it's yes and no. So this is categorical. Now the question is that how data type impacts analysis choice. For numerical data, the options are t-test, ANOVA, and linear regression. For categorical data, the options are chi-square test and logistic regression. And of course, there's some nuance differences in terms of different options, but let me just go to the example and I'm going to use the example to explain this analysis choice. So we come to Excel. This is a hypothetical data set that I randomly generated. And so this column data is two different versions of button, yes, different colors, A and B version. And then this is the minute spent on the app. So this is numerical data. And the click or not is 1 is yes, 0 is not. So this is the categorical data. So let's just focus this one first. So as mentioned that we can use either ANOVA, t-test, or regression to do that. So let's go to linear regression first. So this is the linear regression. We're going to select the Y. And then we're going to select the X. I'm not sure whether it can have this card use letter, but let's see. Okay, and we select the output range. And we click the OK. Oh, one thing I forgot to say. So this macro, I have another tutorial about how to get this macro. I'm going to put a link down below if you are interested in to have this macro. I mean, this macro is not written by me, but it's written by other people. And I'll just use it for the purpose of this to illustrate. Okay, so it means that this macro doesn't support letters as input range, so we might need to change the A as 1 and B as 2. Use numbers as a way to indicate different conditions. So let's see whether it can work. Okay, the output range, we choose the E3 here. So let's click again. Okay, so basically it works. So as you can see that the p-value is 0.01. So that means that the regression coefficient, the slope, is significant. So let's remember this p-value because later we're going to use that. But I guess we can kick it here. Let me highlight here, and then we can come back to compare different p-value. Okay, so this is the first method we use the linear regression. But how about we're going to use t-test or ANOVA? So one way we can do the t-test is let's do ANOVA first. Where's the ANOVA? So ANOVA single factor. And so this is a bit interesting in Excel, but I figured out that the way to work is that here the X and Y, X is conditions. One is minute spent on the app. This is long data format, and it seems that Excel is better to, we can use the wide data format. So what I mean by saying that, so basically we need to recreate A and B condition, two different columns, and then we can copy the data like this. This is A and this is B. And so that's the basic idea, create two columns of data. So then we can select the input range, we can select this as the input range, and we say that they group by column, by different columns. And we have label in the first row. And let's put the output range here, and then we click OK. So as you can see that we're going to get the p-value 0.0135. As you can see that these two p-value are exactly the same. Yes, that means that we're on the right track. So that's this ANOVA is telling us that the differences is significant. Yes. So the main difference is A and B version are significant. Again, this is hypothetical data. We just use it as to illustrate. Okay, last one we're going to talk about t-test. Yes, so we can also use t-test. Where's the t-test? Okay, t-test is here. So it's a two independent sample. Yes, so we are going to say that we're going to just assume equal variance. You can also try the assuming unequal variance. So, but this is not the focus in this tutorial, so I'm not going to go into detail about these two, the differences, but let's just use this one first. So we are going to, this is variable 1 and this variable 2. So basically it's the same. And then we leave this as empty, and then output range, let's choose it here, t-test, yes. And let's click OK to run it. As you can see that the p-value is slightly different from the ANOVA. So the p-value, actually no, sorry, my bad. It's the same actually. I look at the wrong one. So we are going to look at the two tail. So rather than one tail, I look at one tail looks different. Okay, we should look at the two tail. Yes, let me enlarge here. Two tail. So as you can see, the p-value are exactly the same. So as you can see that if the y is numerical data, like minutes spent on the app, we can either use linear regression, ANOVA, or t-test. They will get the same conclusion. Okay, now let's look at another situation where that the y is the categorical data. Yes, if that's the situation, how we're going to do that? So we can either use the, as I mentioned, we can either use the logistic regression or chi-square. So chi-square is a bit tricky. Let me just here use the logistic regression, and if you are interested in, you can comment down below. I might be able to make another video to talk about how to use chi-square, but let me just focus on logistic regression here. So logic regression, how can we do that? There's a logic regression in this macro. So we're going to say that which is x, which is y. Yes. So x is different conditions or different, and then y is the click or not. Yes. And then we have label in the first row, and then we are going to output range. Let's put it here as our logic regression output, and let's click OK. So this is the logic regression output. So as you can see, the p-value is not significant for the regression coefficient here. That means that these two versions of the design doesn't impact the people click it or not. I mean, it's 0.08, so it's still greater than 0.05, so we will consider it as not significant. I think that's it. So I show you like how different data type in the A/B test how we are going to make the data analysis choice. So to summarize, when the dependent manager, for instance, the minute spent on the app is numerical, so which is numerical data, yes, we can use t-test, ANOVA, and linear regression. All of them will get to the same conclusion. And for categorical data as dependent manager, we can either use chi-square test or logistic regression. So earlier I just showed you using logistic regression, so I did not show the chi-square test. So if you are interested in, comment down below. I'm gonna make another video. One final comment is that, so the name A/B test, it seems that we can only have two versions of condition, yes, but actually you can have more than two, yes. You can have like 1, 2, 3, three different versions of the condition. Of course, then in that case you cannot use t-test, but you can use ANOVA. You can use linear regression, but then it's a bit complicated. You need to create some coding variables in the independent variable. So, but it's doable anyway. So, but this is a bit beyond the scope of this tutorial, so I just leave there. And you have questions, feel free to comment down below. And I think that's it. Thank you for watching.